Hey everyone, and welcome to This Explainer. Have you ever actually stopped and wondered what really separates a casual, everyday coffee drinker from a master taster? Well, today we're exploring a truly fascinating concept. We're looking at the idea of taking our own subjective, everyday bodies and transforming them into calibrated, scientific coffee tasting laboratories. We all know what we like to drink, right? But today we're going to dig into the strict methodology that turns a simple sip into hard, objective data. Okay, let's dive into this. The core thesis we're operating from today is that tasting isn't just, subjective poetry. When we talk about sensory analysis, we are talking about a highly rigorous scientific discipline. We aren't just casually drinking coffee here. We are quite literally using humans as biological measuring instruments to evaluate consumer products. It's wild to think about. So, here is our theory to practice roadmap. First, we'll look at the science of tasting. Second, the anatomy of a flavor. Third, coffee's sensorial qualities. Fourth, standardizing the sip. And finally, sensory tests and panels.
All right, part one, the science of tasting, upgrading the human hardware.
So there are 4 recurring pillars of sensory science you need to know. First, we evoke. This means we clearly define our parameters to stop potential biases right out of the gate. Second, we measure. Because sensory science is quantitative, we have to collect data to establish the relationship between the product and human perception. Third, we analyze. We use statistical analysis to figure out the likelihood that a product's characteristics are actually real. And finally, we interpret. This is where we make confident decisions based on the context and the limitations of our study.
Moving on to part two, anatomy of a flavor, mapping the biological palate. Let's start with olfaction, which is our sense of smell. Our olfactory bulb uses over 50 million cilia receptors, 50 million, to perceive volatile roasted compounds. But it happens in 2 completely distinct ways. Orthonasal olfaction is when air is forced directly through our nose. Think of sniffing freshly ground beans. Retronasal olfaction, though, is entirely different. This is when air is forced up into our nasal passage from the back of the throat right as we swallow. Actually, that's the exact science behind why food tastes so weird when you hold your nose. Training our brain to recognize both pathways is absolutely crucial for accurate evaluation.
And this brings us to a really fundamental definition. Flavor is not just taste. Flavor is the ultimate multimodal experience. It's like a giant puzzle combining our gustatory taste on the tongue, those olfactory aromas we just discussed, and somasensory chemical feelings. Those chemical feelings are actually stimulated by the trigeminal nerve in our face, and they give us the perception of spice, heat, or deep pressure. You literally need all 3 of these systems firing to experience true flavor.
That takes us to part 3, coffee's sensorial qualities, translating biology to the brew.
Let's look at how this builds our understanding of basic gustation. We have 5 basic tastes, and each one is linked to a specific chemical trigger. Sweet is triggered by sucrose, sour by citric acid, bitter by caffeine, salty by sodium chloride, and umami by monosodium glutamate. But what is truly fascinating here, like really mind-blowing, is that humans have adapted evolutionarily to detect the taste sensation of bitterness at incredibly low concentration levels compared to all the other tastes. It's a survival mechanism. Now, we really need to clarify a common point of confusion. Astringency is not bitterness. No way. A lot of people argue it's a taste, but it's actually a tactile sensation. Astringency, which is often caused by tannins in the coffee, happens when your body tissues literally constrict and pucker. It actually restricts blood flow and saliva in your mouth. So it's a physical tissue reaction, entirely separate from the basic taste of bitterness. Similarly, when we talk about a coffee's body, we're talking about those tactile, deep pressure senses. The body describes the apparent weight and viscosity you feel in your mouth. This physical sensation is caused by suspended solids in the brew, literally colliding with the liquid. It's exactly what gives us those silky, smooth, or heavy physical sensations as we drink. All right, part 4, standardizing the sip, the rigid laboratory environment. Now, what's really interesting about this slide is just how unbelievably strict this environment has to be. Room temperature must sit exactly between 20 and 22 degrees Celsius because even minor temperature changes actually alter our perception of taste. Relative humidity has to be 45 to 55%, otherwise it physically hinders our olfactory abilities. Even the water is strictly standardized at 55 grams per liter with a very specific parts per million count to completely eliminate taints. The room itself completely dictates our tasting accuracy. And the cupping setup itself, just as rigorous and repeatable. You have to use specific 175 to 225 milliliter bowls. You absolutely maintain that 55 gram to 1 liter ratio. The grind is coarser than a standard V60 filter brew, and the water hits the grounds exactly between 92 and 95 degrees Celsius. But here is an absolutely crucial instruction. You must assess the flavors multiple times as the coffee cools down to see how the profile changes. But you have to stop evaluating before the coffee drops below 40 degrees Celsius. Once it crosses that line, the data becomes entirely unreliable.
Finally, we reach Part 5, sensory tests and panels, calibration and statistical output.
To understand why we go through all this trouble, we have to ask a simple yet critical Socratic question. Is there an actual difference in the coffee, or are we just guessing? Let's say you run a coffee roastery, and a bad crop forces you to replace the Marigoupe from Central America with a Colombia Huila in your flagship blend. You need to know objectively if your customers will actually notice the difference, right? Well, to prove a difference, we have to fight what's called the null hypothesis. In sensory statistics, the null hypothesis states that there is no difference between the products, and any perceived difference is purely due to guessing. So to reject this null hypothesis, we calculate a p-value, which is just a measure of how likely a result occurred by chance. We basically need enough people to find a difference that exceeds our statistical threshold, which is usually a 95% confidence level, just to prove the new blend actually tastes distinct. So how do we get that data? One essential tool is the triangle test. The methodology here is brilliantly simple. You present a trained panelist with 3 coded samples in a specific order. 2 of those samples are identical, and 1 is different. The panelist simply has to identify the odd one out. Sounds easy, right? Well, the crucial point to remember here is 33%. Think about it. In a triangle test, if a panelist is totally blind to the coffees and just guessing randomly, they still have a 33%, or 1 in 3, chance of getting it right. That baseline chance of sheer guessing is exactly why statistical panels require anywhere from 24 to 36 distinct responses. You need enough data points to mathematically prove that the correct answers aren't just riding on that 33% luck. Now, there are other methods depending on what your goal is. The triangle test asks you to find the odd one out among 3 unknowns. But the duo-trio test gives you a known reference sample right up front and then asks you which of 2 coded samples matches that reference. These different discrimination tests are amazing because they allow a panel to root out incredibly subtle changes caused by shifting ingredients, new packaging, or even extended storage. Setting up a panel requires some really critical choices. I mean, are you just trying to find if a difference exists, or do you need to describe exactly what it is? Is it quantitative or qualitative? Most importantly, a robust panel isn't just set and forget. It requires continuous calibration to keep your human instruments sharp. You have to regularly check the aptitude of your panelists, make sure they're aligned with each other, and actively minimize error by feeding their results right back to them for ongoing training. Which leaves us with this provocative thought taken straight from the sensory science material. Are you a human or a robot? Look, we bring our culture, our age, our diet, and our deeply human experiences to every single cup of coffee we drink. But by applying these rigorous scientific sensory tools, by calibrating our environment, understanding our biology, and trusting the statistical data, we can elevate our subjective joy into an incredibly powerful, objective instrument. Thanks so much for joining me on this explainer, and keep testing those senses.